Hello everyone, myself Shweta and my teammate is R. Subhasri. We are from IT department in Welltech High Tech Dr. Rangarajan Dr. Sakuntala Engineering College and our project title is SEIR Model Based Spread Prediction and Vaccine Distribution for COVID-19. Abstract. COVID-19 made a great impact by disrupting the people's day-to-day life and slowing down the global economy. This pandemic has affected thousands of people who were either sick or killed due to spread of the disease, and epidemic growth rate increases manually. In our project, we are used SEIR, which is nothing but a compartmental model where S means for susceptible, E for exposed, I for infected, and R for recovered, which this model used to predict the spread of the disease, total number of cases, and total recovery. And we have tried out efficient technique to distribute a vaccine to the given susceptible population. Scope of the project. In this project, we are using SEIR model to predict the spread of COVID-19 by predicting total number of cases and total number of recovery. And additionally, in this project, we have tried effective vaccine distribution, where vaccine helps to prevent exponentially spreading of disease and also help us to boost our immunity toward disease. Moving on to introduction, let us discuss in detail about SEIR model which we used in our project. SEIR is a compartmental model simplifies the mathematical modeling of infectious disease. These models most often run with differential equation. By using this model, we predicted total number of cases, total number of recovery, and also to found the reproductive value or not. Existing system. The existing system is mostly based on SIR models and some are SIS models. Mostly vaccine distribution is not attempted for COVID-19. R1 for population per million is not calculated. Proposed system. In our project, we have used SEIR model and calculated accuracy. We have tried to find effective vaccine distribution strategy and check availability of vaccine. We have also found reproductive number or not for population has a whole and population per million. Compartmental model. Compartmental modeling describes the movement of a substance from one component to another. It simplifies the mathematical modeling of infectious diseases. The population is assigned in compartments with labeling, for example, S, I, R. Let's have a look on overview of SEIR model. N denoted as total population, S for number of persons who are susceptible, E for number of people who are exposed, I is denoted as number of infected, and R for number of people who have recovered. Hardware and software specification. Hardware requirement. Minimum we need 500 GB of hard disk with 8 GB of RAM. Software requirements. Operating system Windows. We have used Python as a coding language, and the tools which we have used is Colab, in which we have imported the popular Python libraries to analyze and visualize data such as NumPy, Matplotlib, Odient.
Hello all, this is Subhashri and I'll be taking over from this slide. So the formula used in our project. In our project, we are going to mainly find out and predict the total number of cases, the total number of recovery and R1 for million people. So for that, we need to separate the susceptible and export compartment. To find that, we'll just subtract the recovered and infected compartment from the total, that is N. And after that, we can easily find out the beta and alpha. From that, we'll find out the reproductive number R1, which is nothing but the reproductive number for a million people. And that is beta into the population divided by 1000 divided by alpha into 1000. And now, to predict the total number of cases, that is I t plus 1. T plus 1 meaning the next day, we just need to add alpha to the current infected rate. Same way goes to the total number of recovery, that is to predict the total number of recovery of the next day, we just need to add beta to the total number of recovery of today. Vaccine distribution. So, when a foreign particle enters our body tries to create antibodies which will in turn fight with those foreign particles to protect our immune system. So, in this same way, vaccines also will help our body to create antibodies. This is the most effective way of protecting people against harmful diseases. So in our project, we will select the top 5 states which has the highest confirmation cases, and then we will suggest the top 5 vaccines available in our list. System architecture. So we'll first take the population, the total number of population, that is n, and divided it into 4 different compartments, that is susceptible, exposed, infected and recovered. And from here we'll calculate the rate of change, that is alpha and beta. Alpha is the rate of change from susceptible to exposed, and beta is the rate of change from exposed to infected. And from this, we'll calculate the actual outcome and also predict the next day's outcome. From there, we'll find the R naught, which we will use to find the highly affected states and suggest the vaccine to the susceptible people. Data flow diagram of our project. This project starts with the data set of COVID-19 pandemic, and from here we'll try to segregate the SEIR compartmental model. For that, the first step will be separation of S and E from the rest of the population, and then calculate the rate of change alpha and beta. In the next stage, we will compare the actual versus the predicted outcome, which we will derive from the alpha and beta, and then identify the percentage of highly affected state, and then finding the highly affected state using R naught, and then categorize into top 5, and then suggest an effective vaccine distribution strategy. Resultant discussion. We took 28th of March as our demo date, and the predicted total number of cases came around 1 crore 19 lakh 61,440, and the actual total number of cases which fell on 28th of March was 1 crore 19 lakh 71,004. So this brought us to the percent error of 0.2%, and the predicted total number of recoveries was 1 crore 13 lakh 23,728. The actual total number of recoveries came around 1 crore 13 lakh 21,578. This came around to the percent error of 0.01899 percentage, and the reproductive values R0 and R1 came around, that is the R0, the reproductive value of the COVID-19 pandemic was 2, that is from one person it had the possibility of transferring to 2 other persons, and the R1, that is the reproductive stage per million people, came around to be 759. The second module of our project was consisted on finding the percent error that can be calculated through alpha and beta. These are the alpha and beta of the 5 consecutive days that we took. It included 20th of March, 27th, 26th, 25th and 24th. The result and discussion for module 2. In this, we are trying to find the most 5 states that got affected through this pandemic. And our top one list came around to be Maharashtra. In the vaccine distribution strategy, we also find that AstraZeneca was the mostly available vaccine found in India. Conclusion. Using SEIR, the population, which was separated into 4 compartments, we were able to predict the total number of cases and total number of recovery, along with the percent error and accuracy, and we also calculated the accuracy of alpha and beta. And further, we also extended a project to find the reproductive value R0 and as well as the R1 for a million population. And then in the second module, we tried to find the total number of cases and total number of recoveries for 5 consecutive days and calculated the accuracy. We also found that the most infected state in India was Maharashtra, and therefore we could conclude that the vaccine requirement is highly needed there most. And then the vaccine which was abundantly available in India was AstraZeneca. Hope this project helps to be statistically ready to defeat this disease. These are our references, which helped us to come up with various ideas for this project. and we published this in Journal of Zhuang University of Science. Thank you so much for seeing this video.